All right, howdy folks, welcome to NESnet day 4. We are connecting the NES to the internet. We've got our dev cart here, prototype. So far we've got a 32 macrocell CPLD, program, and CHR RAM, and then our little ESP81 board. And this thing is currently connected here. So I have socket server running, and so the device is reading. What's it doing? What? Oh, I'm in. Trying to get my bearings here. GPIO UDP project. So this is what we've got. Our code is pretty ugly, that's right. So we've got a so the ESP is just sending a UDP packet, and here it's constructing the string. So it reads all 4 GPIO, and then it bitbangs on we have a SPI clock pin designated from. So here's the Verilog for our CPLD. Nope. Well, hold the phone. This is. That must be the wrong one. Because so we ANDed our clock. I forget where we were having problems last time. Where did I keep this guy? All right. Got. It's this one. So we have our SPI clock, which is an O-ring of the clock from the ESP and the write signal for 5000. So let's open that project. Yeah. So let's build this and flash our CPLD. Where's my... I don't think I have what's wired up right now. A little disorganized here. All right. Need a cable. We had all those problems with the detect now. We have those problems with the detection. Startup value. So this is my local machine. I got a compile time 11:22 or one. Okay, let's do this one. And our test script here, so it'll write 0 and then read it back. And then so here it connected. So it starts up all set and then it shifts that through each time it reads. We write 0, 1, 5, 8A. We're not getting the exact right values here back out again. But we're getting something. So let's see if we can switch over to platformIO. I have it installed in this machine. The sooner we can abandon Arduino, the better, I think. But let's just go ahead and flash this guy. So I'm just going to swap out for a different ESP. Start with, we're having problems flashing this thing last time too. Okay, so it's writing. I had problems with that one. Everything seems to be going better than 2 weeks ago, last time I streamed this. So I'm hoping that we can I don't know, we get this serial parallel interface working. We need to start work. We need to make progress on the code of the ESP. Actually establish our communication protocol in between the, so that looks good. Let's okay, we're getting similar results. Part of the thing is our timing's different. I also think I might be, I don't know exactly. We'll get into that, but so let's see if we can switch. We can import this project into platformIO. I'm just going to copy it. And then we will what's this? I didn't actually modify it. That's not what I wanted to do. Not know what I'm doing with BS code here. What are you doing to me? All right, import Arduino project. Select a board. I think it's this one. Use libraries installed by Arduino IDE. Highly recommend to use platformIO library manager. Yeah, I think I would agree with that. Internet connection. How do I close this file? What is going on here? I've got like multiple. This is my. I really don't understand this. Remove folder from workspace. Okay, so I think. So this is our code. Let's try to flash this guy. Maybe we'll change something just for verification here. Why do I have multiple homes? Show instruction. All right, maybe we'll do that. Let's just export this guy. Build, upload. Looks like it's going. It's having problems connecting. If you unplug it and plug it back in, it seems to go though. I think that's with the UART settings. Reset method CK. Try this. And then convert our project to C++, I guess. It's not looking good. My imported project does not appear to be working. Why? I don't know about the library situation. Save workspace as. Where are you putting my files and documents? I don't want that. I don't know, I might tinker around with. Yeah, we have to import. I wonder about if I should try to use platformIO without this stupid IDE. But also not sure about change this from. I don't 100% know which board I have. Located in this path that you don't want it at. I've got two different ones now. I can relocate it. Let's just try it again. That chip we knew worked though. It was just working. It's already active. I don't know why you just told me that. All right. This doesn't work. I don't know if I have patience to figure out. I was hoping that things would just work with platformIO importing an Arduino project. We get the blank. Anyway. Stick with Arduino for now. Why my highlighting doesn't work for Vim is beyond me, but whatever. So we need a loop There, it's connected. All right, whatever. We'll stick with Arduino. So we take the interrupt pin low. We have our this is not the right file. There we go. All right, so ESP3, this is our interrupt pin. It also controls whether the shift register is parallel load or serial. So we take interrupt pin low, and then we shift the register. So we shift in bit 1 or pin 1 into bit 7, and then we do a right shift. So it'll shift out least significant bit first. I think I'm going to flip that around, but and then we have ESP2 connected to the lower bit of the SPI register. So here we're assigning the pins 0, 1, 2, 3. So master, we're going to be pulling master in, serial out. So we're going to be pulling MISO. Yeah, so here's let's do this. So I want to set up a better test case here. this thing is currently looping every 3 seconds. And my test appears to be every 3 seconds as well. Let's set this every second. So the INO retro will write and read every second. And let's write a different value, C5 to 5000. All right. So 10 seconds. Hey, Vi. Need to get you Discord, Twitch, chat room. Yeah, I'm quite a ways from being able to do something useful, most likely. So I it would be cool to run your project on here, but I need to understand better how your communication protocol works. I know you're just using the controller, but like I couldn't immediately see how your protocol itself worked, like what's actually managing your packets and everything. Anyway, I just needed just more reading. Yeah. I guess, well, my hardware definition for the board isn't that defined yet, and so I hesitate to say it would be. I hesitate to agree that it would be easy. I mean, if our brains were one, yes. but connecting us understanding what each other is doing enough to make it easy, I think will be the challenge. But I think that'll be a good first step. So we got all zeros. As long as you can do the TCP request and get a response, it should be easy. But what parts of the TCP request? I mean, I can send TCP packets, but it's like, how are you communicating what IP address to send it to? What, all of that stuff, like where is that? Okay, we're getting something. The same thing. And it's It keeps, well, so here, let's do this. I guess the real question is like the thing that I'm not sure we'll have to get on the same page is like knowing the connection to the server. I mean, once the connection and all that stuff is set up, but how are you communicating to me that stuff? Oh, okay. I think part of the thing is I'm just overcomplicating this stuff in my head. Oh, you know what? We never decremented our loop. All right, there's a good way to kill my. There we go. Okay, so here you can see where these every third one, is this thing going? There it is. So every third one, so it after the write, it reads back the same value. That's good. It waits a second and then it reads it back again. If it read back the same value, then the ESP didn't touch the shift register. If it did, then it flushed that value out, and the most bit 7 should be sitting in bit 0, and we are reading back 1. Started out as a taskbot thing, but I modified it to work nicely with a Lua script. Okay. Don't know how to do 32 button presses every 2 frames in Lua. So I just have it do a TCP request for the Lua script. Take the responses, push to the screen. Sure, the controller protocol, but the actual, I don't know, protocol that you have, I know you're sending TCP packets, but the NES isn't actually handling the IP layers and everything. The connection, you're just part of the problem is I don't know enough about what I'm talking about. So we'll get there eventually, though. Right now I can't even move a byte. Well, I can sometimes. So I suppose I could get logic analyzer out. No, you don't. But I have to do it on the ESP, and part of the problem is I just really don't understand things well enough to fully understand everything. So the communicating I don't think I have anything good here to show. Oh. Well, I don't know how to explain what I don't understand. But we'll get there. I got to get this working for the parts that I understand first, and then I'll build on my knowledge, and we'll get there. The ESP, it's its own beast. It's a microcontroller. Here. I forget what cores. It's an L106 32-bit RISC processor based on the Tensilica Diamond Standard 106 Micro. But there's all kinds of Arduino libraries written for this thing. So for this UDP, and TCP is similar. You just make a TCP connection with this host, this IP address, and then you can send packets. For here, I begin a packet, a UDP packet. I designate the server IP, which is my local machine right now, and the port number, and then I write a message, and then I end the packet. And so here, oh, you're fine. Yeah, so that's basically what I'm doing here. Except I'm breaking my message up into multiple writes. Wait a second. Am I actually... Oh yeah, I am clocking it. High, low, high, low. Anyway. So I want to put this in a loop. I think Arduino is basically just C. Or C++. Because here they're talking about converting Eno. Yeah, they're not valid C, C++. No function declarations. But I think the actual syntax is C++. So we first right now with this stuff I'm still here, I'm really just working on the hardware stuff so that I can start getting into more of the internet stuff. So it's starting as low. So I'm setting all of these as output: clock, Mossy, and int. And miso is input. Start with clock, Mossy low. So when I want to read a bit, I guess if I'm shifting so we'll read it, we'll clock, and then we'll take it high again. Let's do this. I don't know what happens if we write a number instead of a character. That's probably not going to work. We need to convert an integer to a character. Anyway, let's just try to run that. It's like, because when we were getting, I can't scroll up far enough. It's like the bits in the middle weren't reading right. I'll put this in a loop and hopefully it'll all start to make sense. Get out of there. This is not the same project. Or no, it should be. It got upset about my syntax error, or not syntax, but it's doing the same thing. Let's so when I write F, it does read F back out. When I do AA, it's all zeros. Okay, so that's I am aware that I'm okay, so it is inverted because I'm shifting, but it looks like we're off by 1 bit. Why is that though? Let's try C0, and I'm guessing that it's going to give us yeah, so we're how many actual shifts are we doing? So the first one, I think we're actually doing, we should get the logic analyzer out. I don't know how well I'm going to be able to connect this guy up. I think I'm going to be scratching my head until I can see the signals. we got this little pigtail right there on the wires. I should have made that longer. I guess I could still make it longer. That would be a nifty way for connecting. Maybe. Before I go down that road, let's just... Maybe it's not as broken as I think it is. So, we're not... It seems that we're off by one bit. So... ESP2 is connected to SPI reg 0. Now if we set, this is bit 0 here. Because in the beginning I just read the GPIO 3 through 0. So bit 3 is set. Which is interrupt. Yeah, and everything else is clear. We should be able to change the master in the MISO pin when we write. Right here, this is no, it's not. MISO is 2. Zero is clock. One is Mossy. And 3. So bit 2 we should be able to set just by writing a value of F. And what do we get? It is set. So that should be bit 0. if we write F E, bit 0 should not be set. And that's right. I'm actually printing 8 bits there. I am. When we write, this is saying it's high when I write F. And it is saying the first bit is high. But what the heck? Yeah, let's connect up the logic analyzer. And really, I think I only need 2 pins. Clock and miso. I need ground, of course, as well. My little stubbies there are pretty small. Think about reclamping that down. But I've only got so much wire there. I'm trying to think if I can figure out some other clever way to connect these to my logic analyzer. If we make a cable? What if I do that? What if I just make another cable? I could have, well, I could put 3 connectors on one cable. I should just made this puppy longer. I don't. I need, well, I don't need 10, but I have 10. 1, 2, 3, 1, 2, 3. That's 10. So I'm just going to take a bit of wire here and clamp on some of these guys, and then I've got some longer male header that should allow us to plug 2 cables together. I just gotta make sure I get the orientation, everything right. So I'm not really going to be able to align pin 1 with pin 1. Still, these guys are. There we got the guy crimped on there. So we'll plug this guy into there. Now our header's in the middle, so we can mate 2 of these together. If I was smart, I would have realized I would want to debug these signals. All right. So this is what we got. Two cables plugged together. We have another. We'll be able to plug the ESP in here, and then I can just strip these wires and we can clip on to see stuff. Basically, I just extended the cable. But I'm not sure I got the orientation and everything right here. How things might have been reversed. So while everything's dead, I think what I'm going to do is have the connector in the middle, the cartridge in the middle, and the ESP on one end, and the logic analyzer on the other. $50-50-90. We reversed things. All right, so ground. All right, so ground's over there now. Such a horrible truth in life. Yes, it is. Okay, ground. I think that's good. Oh, wait. I should. I need to crimp this the other way. Yeah. 50-50-90. You made the cable wrong, Paul. So this is, I should have realized this. I figured I could just flip it, but I can't. So the way this is, I'm plugging it in like this, but really I want to plug it in like this, just like I had it here. So my cable should have, this one's going this way, and the other one going the other way. Just wait a moment while I drop everything on the floor. Probably still good. Disconnect this guy. Now I can re-crimp it the other way. So you can see. Oh, maybe. Little grabbers just pinch the wire. Move it down a little bit so that it can pinch onto a new spot instead of trying to hit the same exact spot. Okay. Got your dog hair all over this. Bandit. So this guy's gonna go in just like it used to, I think. Check that. Wait, what? How is it the same? How do I have the same exact problem? This pin, the corner pin is ground still. I basically want this guy connected like this. I flipped it over and I flipped it this way. Yeah. All right. Let's stop just guessing. All right. Same exact problem. I need each wire to be twisted, each pair of wires to be twisted to undo this mirror. Another idea is we just solder on some wires to the ESP and connect our logic analyzer to that. Let's just do that. I won't be able to swap back and forth between ESPs as well. Well, I can, but if I want to logic analyze, then I need logic wired up one. So let's open up my picture here. This is what we want. Ground And so 0 is clock, and master in, slave out 2. So we want pin 0 and pin 2. We basically want these two guys right here. So just those 3 straight in a row. Ground. I think I'm just going to go ahead and connect all 4. Put them in order. If I don't want to see them now, I want to see them later, and then I'll be just do it and be done with it. I don't have my camera set up very well today, but for soldering, but I'm just going to try to do this quick. So strip and tin 5 wires here on both sides, and then connect one end, just solder one end straight to the ESP. So there we got our wire. Alright, so now we're all tinned up. I don't know which one I want to use. I don't think I care. So just going to wire these guys up here. Try to put them in order. So ground, and then 0 is going to skip to So I got 3 wired up, which is the bottom one, and then the next wire is going to skip one. The next one in line is 0. All right, that was a bigger pain than I thought it was going to be. So I only have the first 3 connected. Ground, 2, and 0. And that's all I really want right now. Hopefully we don't need more than that today. So let's fire up ScanaLogic, Scana Studio. Sent paste bin. Okay, cool. I'll check that out. Connect up my logic analyzer here. I forget which channels which. Make a new workspace. Of course, I want to use the device that's online. All right, so blue is channel 1. Close my cartridge back up. I suppose we should try to flash it. I don't know which one I grabbed, but anyway, it looks like it's not talking to us. So it's probably one that we broke with platform. Oh, there's going. I don't know if it's our latest build, so let's just flash it. With their latest build. And logic analyzer. So channel 1 will be clock. So we'll rename that, and then MISO. Shift register out. Gotta turn it on, and Arduino needs to compile again because, no, maybe I changed the code. All right. Yet another cable draped across my desk. All right, it's flashed. And hopefully it's talking to us. There it goes. All right. So let's wire up logic analyzer. So blue and then yellow. Well, actually, it's probably the other way. Yeah, so zeros, so yellow and then blue. Okay, my camera's all blurry, it looks like. All right. Now we need a trigger on this guy. So let's see, sampling rate 25 megahertz. Whatever. Probably want that faster. But we'll just have logic change on clock. Okay. Let's 25 is probably good enough. Start. It's not getting triggered. Let's do any channel. Maybe I got things mixed up here. Nothing. Do I have ground connected? I think clock was connected to the wrong one. Oh, something happened, but I think that was just me messing with it. It's still going. There it goes. Where's your... Scroll. So we did get a trigger on clock. So let's edit trigger. There we go. So we got 1, 2, 3, 4, 5, 6, 7, 8 clocks, just like I thought. Okay, we got all zeros, but I think that's because it keeps shifting the same thing. So let's write. I think it's currently writing all Fs. Oh, we got to actually. So that looks like I'm expecting. Let's try to write something less generic. Well, and we in the FF worked like we expected. So let's try. Or C3. So the top 2 bits and the bottom 2 bits should be set. Set, and it changes on the falling edge. Clear, 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 clear. Set. So that looks right. But what? Let's see, look at that. We got. It looks slow. When are we sampling? I wonder if. So let's look at the spare log. So when is it supposed to shift? It's supposed to shift on negative edges of SPI clock, which would be an ESP0 goes low. And it looks like it's mostly doing that. This seems like an exuberantly long delay here, though. This one happened right away. It looks like it's just slow for some reason. Well, that doesn't. Okay. So we wrote AA, which is. And we're seeing the first bit. We're seeing bit 0 first. So here's bit 0. We're sampling it here. And then we toggle it. What did we actually read? I think we. Maybe let's. So let's do this. Just for visibility's sake. We take it high. We take clock high. Shortly after that is when we're sampling digital read. And then we take it low. When it goes low, that's when our next bit should come out. Hey, Sakanako. Yes. So we're compiling our sketch right now, but this is our current prototype. We've got a 32 macro cell CPLD, program, and then we've got CHR RAM. We don't have any code actually running on the cartridge yet. We are just using the INL retro to write to the mapper register. So trying to get that working. And once it appears to be working on the INL retro, then I'll get into writing some 6502 code. So we have this socket server running on my local machine. It's just listening to TCP and UDP packets. When I plug, when the ESP32 boots up, it sends starts sending data, and then every 3 seconds it sends the current state of the shift register. So we're having problems with the shift register. It seemed like things were, well, it seemed like I was losing bits, or I should have waited, but when we connected up Logic Analyzer, it seems that it's taking longer for the bits to, they're slow for some reason. And I don't know if it's because of the GPIO type or what. So what we just changed was we take the SPI clock high. So we have some sort of indication in Logic Analyzer as when is the ESP polling the current state of MISO. So it takes clock high, and then shortly after that is when it's going to read the MISO pin. And then it clocks out. So then it takes clock low, and clock low is what's supposed to shift the register. So here's our shift register. So at negative edge of SPI clock, we've got the serial, which should be, we're in serial mode. That seems like it's working. So here's our INL retro test script. We're just writing the value AA. So write that, run our Logic Analyzer, see what it looks like now. So the SPI clock looks a little different. We have a better indication as to when the sampling is being done. So shortly after it goes high, we're sampling in here, low, right? What is the actual? So we did get AA out of it. Look. It looks like it worked. So we're sampling here, 0. We're sampling sometime after here, and it's actually getting it. What's the actual? It's let's measure. This seems so slow. It's supposed to be, it's slow on the rising edge, but the falling edge it's not. So it feel like Be better to see it with a scope, I guess, than a logic analyzer. But let's take a measurement here. So it's supposed to be changing here. 1.6 microseconds? We'll increase the sample rate to 50 megahertz. .58 microseconds it takes for that thing to go high. Why would that be? What are our... Go back to our notes here. What were we getting? Oh, is that our LED pin? Which one's our LED? I think it's 2. So GPIO 2 is the LED. 2 and 2 is meso pin. So there's an LED on that pin. That LED so this is the ESP01S. The other one isn't, the non-S version is on a different pin, but so GPIO2 has, I don't actually know the schematic, but it's a common, well, you got to take the pin low to turn the LED on. So I'm guessing there's a resistor and then this is connected to 3 volts. So could that explain why it's slow on the rising edge? I mean, it should be relatively easy to take that pin high. about changing it so that would it be better for the microcontroller to drive this pin instead of this pin being an input? Can we switch the clock maybe? Switch it. What if we just switch these two signals? We had problems though. This pin has to be high at boot. I wonder how well I can see this on my oscilloscope. I think I can actually share my scope screen with you. So yellow is first. All right. Should I have this guy plugged in? I think maybe let's just start it up and see if it works. Does this thing have to be so huge? I'm trying to remember how this. Oh, I think we go. There, it's running. All right. So we want to trigger on channel 2. You can't see that. There's a viewpoint though that I'm trying to remember. Display. Virtual panel. I think that's what it is. So there, I think you can. It's not very well sized. Let's just go back to this. So I'm going to set, oh, we're starting to get something there. Oh. And then I don't want it free running. There, you could see it there for a second. How do I close that out? Acquire. I want to run it. That's not what I wanted. It's not doing what I want. I'll close this out. Or no, let's just disconnect for scope for now. Not sure if that's missing. Okay. There we go. You gotta go run and then single sequence. So there we go. Oh, but you can't see that. There you can see it now. Let's do 200. All right, let's send some actual data. Well, that's not terrible. I don't know why it's not updating you. I think it only captures it. There it is. Run this again. Single sequence. Whoops. Why is it being dumb? Let's do the virtual panel. You can see it there. I don't know how well it's showing up on stream. It doesn't look great in my preview. You can see those slow rising edges, as I suspected. But it's not. Yeah, it's not great. Wonder how quickly the microcontroller can change these pins. We also have it on slow slew rate. We can set this guy to fast. So let's see if we can measure that. I don't know if you can see my cursor. Doesn't look like it. I'm gonna go to right 2/3 of the way there. Oh, you can see my cursor is just a little delayed. So the falling edge is where it starts. And it's taking 940 nanoseconds. I'm just gonna snap a picture of that. I suppose I could screenshot it. (940 nanoseconds). So let's try to, we got the slew rate changed to fast. on the CPLD. Easy. Easy. .2:06 p.m. That's now. This is the woes of hardware. Sit there and troubleshoot what you think are software problems. No, they're analog problems. All right. Doesn't look much better on the scope. I think you're seeing what I'm seeing. $900 doesn't really change it much. So, what are some potential fixes here? It actually seems to be working when we change the order. So, this for loop that we have where we're bitbanging our serial parallel interface. I mean, really, we want this. We'd really like this to be as fast as we can. What I think I would really like to do is swap some of these pins. So because of this, we've got a slow rise on GPIO2. So that's like the worst. Using the MOSI or MISO, the shift register output pin, which is the input to the microcontroller, that's like the worst pin that we could use. Because we're trying to sample that, and if it takes a while to get there, we're pinning ourselves. So the other thing is ESP01s have an LED on GPIO1, the transmit pin. So these two pins right? ESP01 has it on 1, ESP01S has it on 2. Now, I believe 0 matters for boot. It needs to be high. I think we wrote that in our notes. So to boot from flash, these pins have to be high. To boot from UART in bootloader mode for the UART program, 0 has to be low. Right now, zero is our clock. So this is an output from the ESP. So ESP outputs work well on ESP0. What if we just shift MISO and MOSI? Swap those. Or what if, see this seems to say that GPIO2 needs to be high. They both need to be high, 0 and 2. These both need to be high. I don't know exactly what will happen if it's low. It's not on this table. This is a bad input. Or it's a slow one. If I have an ESP01, this one's slow as well. This 1 and 2 have to be high. Or 0 and 2 have to be high. We seem to be meeting that by having this as an output from the CPLD. These are all outputs. This interrupt pin, I care less about. Clock could also rise slower, and I wouldn't really care. So I kind of want to swap these. We're going to have problems getting the ESP to boot though. Let's try it one at a time. Curious if we change this one to an input. If it'll boot now. Let's try to synthesize that. Disconnect our oscilloscope. All right, 218. Flash this guy. So it's talking. But if we power cycle it, let's see if that LED flashed or not. There it's going. Seems to be okay. Rearrange all these. So what I had and what I have. I ended up switching them around. So what I had was clock was 0. Just gonna write this down quick. So clock was 0, Mossy. So input was 1, miso output was 2, and interrupt was 3. That's what we did. Really what I would like They all seem fine if we only really have, I don't know about interrupt. Interrupt might be bidirectional. So I think I want one to be interrupt. Zero and two are the slow ones. Or no, 1 and 0 are slow, and 0, 1, 0 and 2 are boot. So I think make since this is a boot pin, we'll have this as an input. So master input, this will be miso, mossy. And no, other way around. Microcontroller inputs, master inputs, seem to work well on boot pins. So miso, I don't know if that's what I just wrote. All right, so that's how I want to change it. Maybe let's change it in the ESP first. And the CPLD is all as inputs right now. So we'll change it on the ESP, make sure the ESP still boots with all of these as inputs, and then we can set the output from the CPLD as we want and make sure we're still booting. So this is original bad because so it has slow rising edge. So we're going to do 0 is going to be miso. 1 is going to be interrupt. 2 SCK mossy, like that. All right. Turn my scope off if things kind of loud. SPI clock was not declared. What? Oh, SCK. Get these rearranged, make sure we're booting, and then rearrange them on the CPLD and make sure we're still booting from SPI. So I just hot plug it. It's going. I think we're good. We got our blink. Yep, we're running. All right. So this is what we had. I had problems renaming these pins and changing the constraint editor, but maybe we can leave these as they are in the constraint editor, but assign them as just wires inside here. So so can assign SPI int equals ESP1. Now the way I had these set up before, I was just calling the pin, so I need to replace ESP3 with SPI int. Okay. Now I was using 0 as clock, so I need to replace ESP0 with SPI clock. Oh, I already have that signal. Let's use ESP clock. So SPI Mossy is going to be ESP3. Now, this is serial DIN, which is master out, slave in, master in, slave out. This device is the slave. So I need to replace ESP1 with SPI Mossy. And then we just set ESP0 So these are our old ones. These are our new ones. ESP0 needs to be output. Clock is 2. Mossy is so like that. Let's see if that synthesizes. Probably change my drive strength back. Everything is slow. I changed these from inputs to outputs though. Let's just set these to 3.3. Save those. Power up should be set. And we'll redo it. mad about this for some reason. Oh, I think that pin's not being used. All right. Let's reflash our CPLD. And maybe, just maybe, it'll boot. .236. All right. Do we get a blink when we plug it in? We got our blink. Looks like it's on. Let's try writing some data. Looks good. I wonder how our signals look. Let's just use the logic analyzer for now. It's easier to see. Oh, these pins aren't going to be right anymore because we changed them. I got pins 0 and 2, and pins 0 and 2 are MISO and clock. Oh, I guess they're right. I just swapped them. Maybe. Yeah, so this is clock. This is that looks better. The edge is nearly simultaneous. And we are booting. And we're moving data. Okay. What now? I don't know. Maybe let's we're generating this stream, but instead of generating this stream, all right, this is probably gonna be extra slow because of this is probably a longer function than doing something as simple as a bit shift. So data equals 0. we're reading bit 0, data equals data shifted by 1. Oh, wait. Plus 1. This ends up being plus 0. We could also do, we could do the shift separate. So in that case, we just do the data plus equals 1. So it starts off as 0. If the first bit is set, we add 1. Else we don't do anything. Then is there a function for Arduino? Int to char, a to I, whatever. Can we just so let's try that. Let's see if it's much faster. So this whole loop was, we had 45.7 microseconds. All right. I might have to take a quick break here in a minute. Now this is gonna I don't know what this is gonna actually print. Converts the value to a char data type. It doesn't actually perform the conversion. It's just a casting. So it's probably going to print the ASCII value. If I want to see it, printed nicely, then I have to, anyway. Test. Testing. Okay. My mic's working. I'm going to take a quick break here. But that worked better than I thought it was going to. Look at that. We have AA. It's converting it to hexadecimal and everything just like I would have really wanted it to. So cool. Let's try this just real quick. So 158A F. Oh, I don't think I'm going a little too fast. Interesting. Anyway, I'm going to take a quick break. I'll be right back. So is it just coincidental that AA converted to so if we want to print what do I actually want to see? If I convert each nibble so if we have 0, we want to print an ASCII 0, which is 48. But an ASCII A would be 56. Can we, I mean, all we're really doing is making it trying to make it a nice readable format. Let's look at our timing quick. I need to change this trigger. So our polling loop is now 29.7 microseconds. Morgan just got home. I need 1 second. So yeah, we want to print this byte. Let's look up UDP write. Really want to convert to a string. I think okay. So I think we can say string. The default's base 10. We can just do string hex and it'll print it as hex. So I think we can do that. It's painful how long it takes to test this to find out. Some library we need to what's the actual error? Oh, it's capital S. Let's see if that works. I think I need to assign it. Let's do this. Maybe. Oh, arduino. No matching function called. It's looking for a pointer to a string. Wondering if I need to copy it. So I can just do test. No. You can send it buffer size. So can we say 4? And then if you send it a pointer, then you need to tell it how long. Maybe. Still don't like it. Yeah, I got that working. I want to see the other. An array to send as a series of bytes. I'm sending it a pointer. So I think string. I don't understand Arduino strings. It's a string class. Constructs an instance of the string class, multiple versions, a constant string of characters in double quotes, i.e. a character array. Char array. Copies the string characters to the supplied buffer. So we say so then I want to say byte string dot to char array. Data array 2. Let's try that. Oh. Like that? Maybe? Just maybe? I have no idea what I'm doing. Too long. Is there a null terminator? Looks like maybe it worked. Well, compiled. So what next? Assuming this is actually working. We need to be able to read. We need to start implementing some commands. We're transferring a byte, which is great. At least I think we're transferring a byte. One. Let's try. Oh. Do I have to copy 3 over? But it's either 0 or 1. So we have a data array, character array, 0x, write it. And it is writing 0x. And then we convert data I'm not actually sure the shifting is right. Let's try. So we should be able to just do so if this equals A5, convert that to hex and then print it. Didn't like that. Yeah, because I think you got to do like you wouldn't see. Just don't like that. Let's just do it in decimal. just so 165. Oh. How is this actually? So you always give it an integer value. And then you tell it which base you want the string to be in. This because I'm not sure if my data shifting is working up here. Just make sure that it's printing how I think it should. Test A5. There it is. So this does work like I think it does. This lack of highlighting is terrible. Is it like always showing me the last bit? Let's try that. Oh, look at that. FE. There it is. $14. Huh. One F. FE is my oh, wait a second. Bit 0 comes out first. Wait, no. LSB first. Shift to the right. Shift bit from so it's like that. If that bit's set, it'll end up, you put it in the MSB, but then we'll shift it to the right. How do we... OX. All right. FE. So it seems like we're flipped. Because I'm having such a hard time with this, but we're sending FE and we're getting 7F. So that's 1 1 1 1 1 1 1 0. And we're getting 0 1 1 1 1 1 1 1 1. Part of me says I want to change this to shift. I don't want to go recompiling. But is the problem, let's try a different value. Oh, bandit. So we're getting 6 6. CC. Are we shifted by 1? Bandit. Let's do C3. So instead of C3, we're getting 61. Yeah. Yeah. Damn it. C3, and we're getting 6 1. I think we're shifting 1 too many. We only actually need to do 6 shifts. When we do this last read, we're done, and then we end up doing 1 more shift, which is wrong. We could account for this by adding 1 extra, or moving our bit over. Or if we shifted first, that would account for it as well. Or if we pulled our first, what's faster? Let's do this. So we shift it and then we add it. So the last add. And I think this will work if we do an 8-bit value instead of an integer. But I don't think it's really gonna. It's not an 8-bit micro. All right. Getting data. FF C3. C3. There we go. So we got 01, 5, 8, A5, C3, FF. There we go. See how fast that is with our logic analyzer. Just measuring from the trigger? I guess so. .4 microseconds. That font is tiny. So there we go. We moved a byte. Let's maybe clean up some of this junk in here. Don't need this. Don't need this. So now that we have we've got the INL Retro would be 6502 being able to write values and the ESP reading them. So our SPI bitbanging works for reads. We need to implement something for writes. But we are transferring data one direction. So yeah, let's just wrap this up, do a quick recap here. We were having problems with our serial shift bit or serial parallel interface or SPI register shifting. We were bit banging from the microcontroller. We're getting funky values. I couldn't figure out exactly why at first, so we put our logic analyzer to it. Got the logic analyzer out. Here, I'll show writing values here. Let's catch something more interesting than 1 or 5. There we go. So I think we caught A5. So the low LSB is first, and we sample shortly after the rising edge. The next bit shifts out on falling edges of clock. So here you can see this is our data out, and this is our clock generated by the ESP. So it is working pretty well. We had a problem where on rising edges, you can see here's the falling edge and the rising edge is right there. Well, it was delayed like microsecond or something like that. Couldn't figure out what the falling edges were right on time. Well, come to find out, the pin that we had signed was actually the pin that's used for the LED. Well, that extra load on the pin gave us something that looked like this junk. So here's the clock in blue. And this rising edge was taking 940 nanoseconds to get to 2/3. The falling edge is good, but that rising edge, not so much. So we moved the pin assignments around and got that all working. It's this little stuff that can really suck up time, but that's how it goes. So we were able to get data out, but things were slow. Didn't want to have to slow down things to wait for this rising edge. Move pins around, and we'll use this pin for something that we're less sensitive to rising edges for. And depending upon whether an ESP01 or an ESP01S is used, the LED moves. So these are the two slow pins on the rising edges clock. And I don't know if it's actually going to be slow with the microcontroller driving it. It might be a stronger drive strength than the CPLD. But don't really care. The falling edge is the edge is actually doing stuff. Anyway, we fixed our problem there, and we were just writing a 0 or 1 for bits being set, and now we actually have a data byte set to 0. We start off by shifting it to the right. Then we basically set bit 7 if the digital read was high. Otherwise, we don't do anything. And here's where we're setting clock low to shift out the next bit. Yeah. So then we have some Arduino conversion and printing out our value. That took way too long to figure out, but wanted to have a nice printable conversion from a byte to text, so we can just have that message for debugging. Anyway, so we are successfully transferring data. There's no real interlock as far as timing. It's just the ESP pulls the register every 3 seconds, and the INL retro sends writes to the register every 3 seconds. So technically, if those happen to collide, yeah, data transfer. So we only have this going one way right now. So we need to use now we have data, but like that byte might, we have to come up with our communication protocol. And I've kind of thought about this. Some sort of command set. I have ideas for having like registers, variables inside the ESP to abstract away the internet stuff from developers who don't really care about that and are fine with just relatively slow registers inside the ESP. So but then we can have longer ones for sending messages, and then we can say which message, we have to say, okay, so come up with protocols for saying, give a command, say send TCP message, send UDP message, connect to this server, whatever. Yeah. I don't have fun with any of the network stuff. I mean, I should say I don't have fun. I just I don't enjoy it as much as, although if you've been watching me, I haven't exactly been enjoying myself with all of these problems I've been having, but that's just kind of the way it goes. It's yeah. So in the low level network stuff, right, is probably fun for you, right? You understand it pretty well, but for not every NES developer understands network anything. A lot of them probably don't. I think that's safe to say. Don't have any real interest in learning. They just want it to work. So kind of my first idea for we could implement a game with this is have a register in the ESP, right? So we'd have a command set for, update this register value. Or I call them variables. So update this variable or read this variable. Yeah, and yeah, you enjoy brain fuck. Yeah. Don't use brain fuck for your first. Wasn't there somebody that you recently suggested and they took you seriously? Yeah. So the first game that I kind of want to try to do, or basic functionality, is there's a variable inside the ESP. You update that variable. Well, it could be something as simple as the controller read. Oh, they got your cartridge inside. There you go. Poor kid. But you can write the current controller value, and then there'll be another variable, right? An opposite variable so that would be write only, and then there'd be one that's a read only, and you could read that, and that would be basically reading the second controller port. You would write to variable 1 for your current controller. That write would get sent to the other cartridge and update variable, the read-only variable on that one, right? So the other cartridge would be doing the same thing, so you'd have this pair of bytes, variables. One's read-only, one's write-only, but they mirror each other for the opposite console. So you could read second controller just by reading that variable, and you give the other console that variable by updating the variable for the controller state. So things could be unaligned there, right? Like that'd be good for if you have frame accurate stuff going on with controller inputs, that'll create problems. But if that latency is not a problem, then you can do quite a bit with just that alone. But you need messages and stuff like that to actually get data. Like if we want to do Vi's Twitch chat client, right? We need to get TCP data. Yeah, I've looked into it a little bit. It looks kind of interesting. Well, part of the thing is like, to some degree, I'm only going to go so like I'll create some of these like abstractions that will help some people get started. I probably will need help with like I don't really have much interest in writing server side stuff. So part of me favors initial steps that's just peer to peer. Peer to peer is also going to be faster. And people are like, oh, the NES can't handle that. Well, the NES isn't doing it. The ESP is. All the NES is doing is updating these variables. Phone's going crazy here, but anyway, the next steps are going to be actually giving data back to the console, or right now, just the INL Retro is in place of our console. I also want to use interrupts, so the INL Retro or the console writes to the SPI register, and that will interrupt the ESP, and the ESP will go and fetch that byte. So that way, we need interrupts, and then fetch that byte. Oh, what is the, or maybe there's a sequence of bytes. Oh, wait for more bytes, or go back and wait for more interrupts to fetch more bytes, and then process that command and give data back to the console through the SPI register. So we need to get data going the other way. And yeah, I tried to, Arduino still driving me bonkers, but it is working. I think I like platformIO better. I don't know if I like this IDE. You don't need VS Code. Anyway, so I might tinker with some of that stuff offline, or I don't know if I'll actually have time, but yeah, we did succeed today in bitbanging a byte. And we'll just keep chipping away at this and see how it goes. So have a good week or weekend. We'll see you guys next week.